I want to talk to you about the domain of a function that is the set of all possible input. Let me write it down. The domain of a function is the set of all possible input for that function. What do I mean by that? Consider the function f of x, something like 4x plus 1. Now notice that I can let x be any values. There's nothing you can do to make this function undefined. So x could be 10, negative 10, 5, negative 50, whatever you want it to be. So the domain of this function is the set of all real numbers, or more commonly, you could say from negative infinity to positive infinity. But if you have some function, let's say g of x equals square root of x. Now notice that x cannot be a negative value because a negative number, square root of a negative number, is a complex number. So the domain for g of x is from 0. 0 is the smallest value that you can assign to x, all the way to positive infinity. Okay, let's do some more interesting examples. Say that we want to find the domain, for, say, f of x equals square root of x to the second minus 2x minus 8. Now here I know that x to the second minus 2x minus 8, collectively, all that must be greater than or equal to 0. Now notice that if I factor the left-hand side, I get x minus 4 times x plus 2, and that has to be greater than or equal to 0. So I know the boundaries for the domain, or what we call in math critical points, are positive 4 and negative 2. How do I know that? By setting each factor equal to 0. So if I say x minus 4 equals 0, I get x equals 4. And if I say x plus 2 equals 0, I get x equals negative 2. So the critical points are at negative 2 and positive 4. What can I do here? I'm going to test numbers to the left of negative 2. I want to know if the numbers to the left of negative 2 are those part of the domain. How do I do that? I can pick a number, any number to the left of 2, and assign that number for x. So let's say to the left of negative 2, how about negative 3? If I plug in negative 3 in here for x and negative 3 in here, and I get negative 3 minus 4 is negative 7, negative 3 plus 2 is negative 1, negative 7 times negative 1 is positive 7, and positive 7 is greater than or equal to 0. So I get a true statement to the left of negative 2. How about the negative 2 itself? If I plug in negative 2 for x, notice that this part, this parenthesis becomes 0. Negative 2 plus 2 is 0, and 0 times anything is 0. And 0 is greater than or equal to 0. So I'm going to put a t on the top of negative 2. Between negative 2 and 4, an easy number to test is 0. So I'm going to assign this time 0 to x. When x is 0, I get -4 plus 2 times plus 2. I get -8, and -8 is not greater than or equal to 0, so I get false in here. Similarly, I can assign 4 for x. When I assign 4 for x, I get 4 minus 4 right here is 0. 0 times anything is 0. So it gives me a true statement. And to the right of 4, say 5. If I plug in 5 for x, I get 5 minus 4, that is 1. Then I have 5 plus 2 is 7. 1 times 7 is 7. And so 7 is greater than or equal to 0. I got a true statement in here. So what is the domain of this function? The domain of this function is the set of numbers starting from, from smaller numbers. So -infinity all the way to -2. -2 is included together with from 4. 4 is included all the way to +infinity. And so sometimes here students ask that how come if infinity is included, why don't we use a bracket? And the answer is that, infinity is really not a number. So it just keeps going both to the left and to the right. So it is something that we agreed upon, that not to use bracket for infinity. Let's do another example. Something as easy as, or as hard as, f of x equal 2x to the second plus 10x minus 12 all over x squared plus x minus 6. So notice that f of x has no restriction on the numerator. There's nothing you can do to make the numerator undefined. However, the denominator, this x squared plus x minus 6 cannot equal to 0. So first x squared plus x minus 6, I'm going to set that equal to 0 to find out what values of x would make the denominator undefined. So this becomes x plus 3 and x minus 2. So now I have x plus 3 equals 0. That result 2x equals -3. And when x minus 2 equals 0, x equals 2. So what is the domain of this function? The domain of this function is the set of all real numbers, okay? Or some textbook, they say x such that, set of real numbers x such that x cannot equal -3, 2. Another way that I personally think makes more, it's easier to remember, is to say that the domain is from -infinity all the way to -3, together with from -3 to 2, together with, or union from 2 to infinity. Notice that it is, I'm starting all this from negatives. I'm starting from smaller values and working to the higher values. And so let's see, let's do one last example. How about something like f of x equal square root of x to the second minus 7x plus 10 all over x minus 8. So notice that this time, both numerator and denominator give me restrictions. The numerator tells me that x squared minus 7x plus 10 must be greater than or equal to 0. And the denominator tells me that x cannot be 8. X minus 8 equals 0. X equals 8 is excluded value. Why is that? Because when x is 8, the denominator is going to be 0. And so f of x will be undefined. So once again, for here, I'm going to say x minus 2, x minus 5 must be greater than or equal to 0. So the critical points are going to be positive 2 and positive 5, setting this equal to 0. And testing numbers, if I test a number to the left of 2, let's say 0, and I plug a 0 for x in here, okay, I get negative times negative 2 times negative 5 is positive 10, so true. That gives me a true statement. 2 itself, plug in 2. So that's going to become 0. 0 times anything is 0, so I'm going to put true. Between 2 and 5, let's say 3. If I plug in 3 for x, 3 minus 2 is 1, and then 3 minus 5 is negative 2. Negative 2 times positive 1 is negative number, and so it cannot be greater than or equal to 0, so false. So I have false statement in the interval between 2 and 5. How about 5 itself? What if I plug in 5 for x? If I plug in 5 for x, then notice that 5 minus 5 is 0, and 0 times anything is 0, so that is, and 0 is greater than or equal to 0, so this is true, 5 itself. And to the right of 5, let's say 6. If I plug in 6 for x, I get 6 minus 2, which is 4, times 6 minus 5, which is 1. So 4 times 1 is 4, and 4 is greater than or equal to 0, so true. So what is the domain? The domain, notice this, so starting from negative infinity all the way to 2. Together with, I'm starting again from 5. Oh, 2 is included, so I have to use bracket for 2. 2 itself is included, let me use bracket. Then 5 is included. 5 all the way to what? To 8, because we said 8 is excluded value. 5 to 8, 8 is not included, together with from 8 to infinity. Okay, great. Let me know if you have any questions. Thanks.